Hello, my name is Elberzhager and I'm from Fraunhofer Institute for Experimental Software Engineering in Kaiserslautern, Germany. I and my colleague Philipp Neuschwander will present results from our paper using a smart city district simulator to test new digital services. The results we present are developed in the so-called PFAF project. PFAF was a former steering machine company in our city, and since some years we redeveloped this district with the goal to have a climate neutral smart city district. We, as one partner in the project, are responsible for digital solutions. So the idea is that we concentrate on different topics, things like mobility, energy, smart home, and further topics are relevant for us. And we would like to develop digital solutions to support this climate neutrality or climate friendliness. We would like to develop different digital services running on some kind of platform, and those different users can then use such services, and we would like to support them when they use the services with their climate friendly behavior. However, if we think about a concrete platform where such services are running, such platforms are usually very complex. You need to adhere to certain qualities like performance or data protection. And that was an environment for us where it was difficult to develop and test new services. Furthermore, we had the challenge that the construction work was not as fast as expected, and we need a technical environment where we nevertheless could test certain new ideas. Therefore, we developed a so-called mock platform. A mock platform is a very simplified version of such a platform. On such a platform, we have some basic services, like a user service or storage service, for example. We have some communication protocols, like MQTT. And of course, we could run different ideas or prototypes on such a platform. Concrete and further ideas can be found in the reference here. However, we further developed this platform and added a so-called simulator component. So the idea is that we even would like to have a better support for exploring and testing new digital services and sensitive services. And we would like to support developers in doing so. So the idea is that developers can prototype their concrete ideas for new digital services. They could explore technical feasibility, so get early feedback about technical issues. And they can just present it to the public and also get some early feedback from them. You would also like to show the digital solutions with more visual components so that it's easier to imagine how the digital solution runs, how it looks like, and even get some more feedback and reactions from others to test these new ideas. So to summarize it, we would like to foster exploration and evaluation of new and early solution ideas in this technical environment, and we would like to introduce others in using this technical platform. Further details can also be found in the reference shown here. And some more details about the Smart City District Simulator are next presented by my colleague Philipp.
So let me introduce you the general idea of the Smart City District Simulator. We want to focus on environmentally sensitive services that are services that react to and or interact with the environment. They will consume data about the environment from sensors as input or stimulus, and they might control actuators in the environment by invoking their technical control interfaces. Sensors and actuator control interfaces are the connections of the services to the environment. We can substitute the real environment, the real sensors and real actuators by using software components. The real city district, the PFAF quarter, which is currently not yet available, is substituted with our Smart City District Simulator that provides a virtual city district similar to the future PFAF quarter. One can say the underlying world implementation is just an implementation detail of the sensors and control components in use. So this is the general idea of our Smart City District Simulator. Based on this general idea, we developed a concept and a reference implementation. The reference implementation is composed of several components. For example, we have a component that centrally manages the state of the virtual world. There's a front end that makes the state of the virtual world observable for humans. And furthermore, there are other components, for example, like the sensors, the actuator controls, and an example environmentally sensitive service that uses those elements. We have taken care in the implementation to ensure that the software components can easily be reused and adapted to realize individual, different scenarios and services. The intended modification points are marked with a wrench icon in this diagram. Our goal was that it is as simple as possible to develop as fast as possible own scenarios and solutions. We want to support quick prototyping of ideas to accelerate innovations. Developers of smart city solutions can take our reference implementation, reuse the components, and modify the parts as needed. Let's now take a look at what the simulator looks like. So our front end of the simulator that visualizes the virtual world. As a starting point, we used the plan of the future FAF quarter and changed its orientation a bit for simplicity. Afterwards, we derived a virtual world from it, which is composed of many different fields. From this, we created a front-end application with supporting controls to help navigate the world. Within the fields of the virtual world, we can recognize entities such as pedestrians, cyclists, cars, streetlights, and so on. And to bring some initial life to the simulator, we added several scripted sample inhabitants to it. In addition, we have developed and integrated a remote control function that enables manual control or movement of the elements in the virtual world. Users can, for example, move a virtual person in the virtual city district and, for example, selectively move it through the detection range of sensors. The reaction or action of the services in response to the stimulus can also be observed in the front end. Here's a short video recording demonstrating this using a pedestrian and a service for on-demand street light control. We will navigate the pedestrian into the sensor range and the light will turn on. And we will navigate the pedestrian out of the sensor range and the light will turn off. Now that we have a good basic understanding of the MOG platform and the simulator, let's talk about using the Smart City District Simulator to test new digital services. We have brought together the following elements. Our project context, so the transformation of the FAF site into a climate-neutral city district, the topic of digitalization and the vision of developing solutions in the context of a digital city district platform to support sustainability and climate neutrality, our MOG platform and the simulator, and motivated citizens who want to help shape the FAF quarter with their ideas for digital solutions. These are the 4 elements we brought together at the FAFHack hackathon. The FAFHack was an annual hackathon as part of the Enstadt FAF research project and was hosted by us in Kaiserslautern, Germany. The last hackathon was the 5th FAFHack and took place in November 2022. It was a 24-hour coding event and we had 35 participants divided into 9 teams. The participants were mainly students and young professionals with a technical background. Their challenge: how can information from and about public spaces help citizens behave more sustainably? Their task was to create a solution concept and present a program prototype. The main goals for us were to collect ideas and prototypes for digital solutions and to encourage civic participation. As a secondary goal was to get feedback on the Smart City District Simulator itself. Since the participants of the hackathon were not familiar with our technical environment, so the MOG platform and the simulator, we carried out various onboarding activities to enable the participants to use our environment at the hackathon as quickly and effectively as possible. Regarding the actions we took before the event, we provided them with documentation of the MOG platform and its services, including the simulator, source code examples, explanatory videos on YouTube, and an online escape game called Perfect Adventure, so to say a playful approach to get to know our environment. During the event, we held a tech talk and explained our environment and the concepts behind it. Furthermore, we supervised the participants during the event, observed their progress, gave hints, and answered questions. Let's now take a look at the teams that have used the simulator. 3 out of 9 teams have used the simulator for their prototypes. There was Team Grid Scorer. The idea was about gathering utilization information of public spaces to support decision making in the field of spatial planning. They collected utilization information over the course of time and implemented functionality to visualize the aggregated data as a heat map. There was Team Hacking.exe. The idea was to install a sustainable workout area with kinetic tiles in the 4th quarter that generates energy from the athlete steps. And on top of this, they added a gamification approach via a mobile application that offers real-time statistics, leaderboards, challenges, and daily goals, and so on. They used the simulator to generate sensor data as input for their mobile application. And there was the Team Bike Punks. The idea was to dynamically adjust the usage of the roads to the needs of the people and encourage sustainable and climate-friendly mobility. Their solution looked like this. Let's have a closer look at the idea and the solution of the Bike Punks team. So the Bike Punks team addressed the issue that there are too many cars on the road and that there is not enough space for cyclists and pedestrians. Their approach is to adjust the usage of the roads to the needs of the people and to encourage sustainable and climate-friendly mobility. They want to provide priority to road users worth protecting by introducing speed limits or other usage restrictions. But instead of introducing static restrictions, they have the idea to establish a smart solution. The smart solution will monitor the utilization of the roads and dynamically adapt the usage restrictions according to the needs of the people and the goals regarding climate-friendly mobility. So for example, given that there are many cyclists on the road, they could be temporarily assigned with their own lane and or speed limits might be introduced to provide them with more space and safety. This is how the Bike Punks sketched their technical vision of the smart solution. There will be sensors to capture and provide information about the utilization of the roads. This information is processed by the services that set priorities and decides about appropriate usage restrictions. And the usage restrictions will be applied and rolled out by controlling several actuators, for example, digital traffic signs or traffic lights, and so on. You might notice that this depiction is quite similar to our initial depiction to explain the general idea of environmentally sensitive services and our smart city district simulator. So it looks like our solution, the simulator, is well suited to support the envisioned prototype. And this is how the implemented prototype looked like in the simulator. We can see the usage restrictions currently assigned to the street lanes indicated by the color of the lanes. One was able to observe the changes in the usage restrictions over the course of time, depending on the respective utilization of the road sections. Let's have a deeper look into their use of the simulator. The team copied our modified gameboard simulation component to create their own actor scripts for a group of cyclists riding their bicycle in the virtual city district. They copied our gameboard sensor server component and implemented their own sensors. The sensors took care of observing the utilization of several road sections and publish it via the event broker, determine the new usage restrictions to be assigned to the road section, and modify the properties of the fields in the gameboard backend to reflect the new usage restrictions. They copied our gameboard frontend component and modified it to draw the fields in different colors depending on their usage restriction, so they become observable for human observers of the visualization. They used a screenshot of their gameboard frontend for the final presentation, and there we noticed that they have assigned the sidewalk to cars and that the entities using the road do not comply with the usage restrictions. So for example, there were pedestrians walking on the car lane. You might have noticed that some points in the slide are marked using italics. Those are observations that we want to discuss further as they seem strange to us. Let's have a deeper look into them. The team implemented multiple concerns in their sensor. It's a mix of sensor, environmentally sensitive service, and control component. One can see this easily when comparing the architecture of the reference implementation with the architecture of their prototype. There's a gap. Everything is combined in the sensor. They have no dedicated component for an environmentally sensitive service or for those control components. We were unsure whether they did not understand or see the benefit of having the components separated. So we spoke with them and they explained to us that they were aware of it and just tried to save effort by implementing it as a single component. We think this is a legit shortcut, as the main goal is to present their idea and prototype to get early feedback. The technical maturity of the implementation does matter, but in case of doubt, it's of secondary importance. But nevertheless, the trade-offs regarding such lack of component separation should be checked in more detail. In the visualization, we observed that there are 4 lanes with usage restrictions and that the original sidewalk has been assigned to cars. Furthermore, we observed that the entities within the virtual world do not comply with the usage restrictions. So there are, for example, pedestrians walking on the car lane, cyclists on the car lane, and cars on the cyclist's lane. Let's have a deeper look into these 2 observations. So, first, they assigned the sidewalk to cars. We were unsure whether that could make sense in the city district and spoke with the team about it. And the explanation was that a given city district layout was not ideal to support the envisioned scenario. So they repurposed sidewalks to have 4 assignable lanes. We understand this as a request for a feature to enable customization of the simulator's layout so developers can adjust it to better support their prototype scenario. What we think about this feature? It depends. On one hand, it could be a signal that the solution is not applicable to the future FAF quarter and therefore the solution should be changed to fit the FAF quarter. But on the other hand, having a fixed layout could be too limiting. There could be interesting solutions for other city districts or alternative design options for the FAF quarter. As an outlook, we want to check the possibilities and implications regarding support for customizable layouts in more detail. Second, the entities using the roads do not comply with the usage restrictions. The explanation for this is that we provided the teams with a single shared instance of the gameboard backend. That means there is only one single shared virtual world that is used by all the teams. The world contains the scripted play provided by us, the example inhabitants, content of other teams, and the content of bike punks themselves. The scripts do not consider the usage restrictions. They only have hard-coded, coordinate-based movement paths. So maybe we should have provided the teams with their own individual simulator instances so they have full control over the world and can adjust everything to support a clean and coherent presentation. What we think about it? It also depends. So on one hand, it might be interesting to have all the teams share one instance of the world and explore how they can interact, connect, and influence each other. Different solutions might complement each other. Furthermore, in a real city district, solutions are required to coexist and integrate with other solutions. To that extent, a shared simulator instance might be a more realistic environment to test services in the context of a smart city district with a digital city district platform. But on the other hand, individual instances could prevent interferences and provide the teams with more control over the environment and their scenario. But it comes with the trade-off that it will isolate the solutions from each other. As an outlook, we want to check the benefits and trade-offs regarding providing a single shared instance or providing individual instances in more detail. To conclude, in this presentation we spoke about the Smart City District Simulator. It enables us to explore and test new digital services for a smart city district that does not yet exist. Furthermore, it fosters civic participation and discussion. We spoke about the application of the Smart City District Simulator in a hackathon event, the onboarding activities and the provided material, the 3 teams using our simulator to implement their prototypes, and we shared the experiences gathered during the event regarding the use of the simulator and discussed our observations. Based on our observations during the hackathon event and the participants' feedback, we can conclude that the participants were able to use the simulator to their advantage. Furthermore, we learned how the simulator can be further improved. As an outlook, there are 2 directions we want to point out. The identified possible improvements can be further investigated and addressed, for example, the individual instances and the customizable map layout. Besides of that, we believe that the simulator can be used in other domains or contexts as well, possibly in the field of digital farming or Industry 4.0. Thank you for listening. We hope that you enjoyed our presentation. For any questions, please do not hesitate to ask them. Thank you.